So this video is on indicators. It will likely be the shortest video all year because it's only 2 slides long and there's not a lot to write about it. So indicators. So what you need to know about indicators, they're chemical compounds that are used that use color to estimate pH. So they change color depending on what pH they're in. So if they're in an acidic solution, they'll be one color. If they're in a basic solution, they'll change to a different color. So some examples are bromothymol blue, phenolphthalein, and universal indicator. You've used phenolphthalein already. That's the one that turns clear to pink. You can see bromothymol blue. It's yellow when it's in an acid. It's green when it's more neutral, and it's blue when it's in a base. So you can see depending on which pH it's in, you can see different colors. It's used to estimate pHs. And you've seen we've used it in titrations where you'll add a base until it turns pink. So phenolphthalein is great at telling you when your reaction has been neutralized. Speaking of neutralization reactions, or of being neutralized, that is where you have an acid and a base react to each other. They neutralize each other to form water and a neutral salt. Well, I guess sometimes the salt is neutral, sometimes it's not. But for the most part in this class, we're always going to be reacting a strong base and a strong acid and a strong base, which will always yield a neutral salt and water. So this is a double replacement reaction. The H and the Na switch spots, so you end up with HOH, which is where you get your water, and then you end up with NaCl. So that's your generic acid-base reaction. Well, a general acid-base reaction. It always makes water and a salt. Now, the next thing I'm going to quick show you is here is a list of different indicators. And you'll see on top you've got a pH chart, 1 through 14, acidic and basic. Now let's find phenolphthalein. So phenolphthalein, you can see it actually transitions between a pH of 8.2 and 10.0. So that's why when we do the titrations with phenolphthalein, notice here's a pH of 7. We want to stop the reaction right when the reaction is neutralized and your acid and your base are perfectly reacted. That's why I'm super fussy about you finishing the reaction right as the pink just initially starts. So right when you get that very, very light pink, that is when the reaction needs to be done. That's when you're done. If it starts to get dark pink, that means you've gone too far, so that's why I've had you start over in the past when we do those reactions. But phenolphthalein is very nice because it goes from clear to pink, which is a very obvious transition. Not all indicators have really obvious transitions like that. I'm trying to look at another example on here. Thymolphthalein goes from clear to blue, but you can see it might be hard if you want to check this light blue to dark blue. That's a really hard transition to see. Same thing if you're trying to titrate something to where you need it to stop at a pH of 3. The difference between yellow and orange is a very difficult transition. So you're not going to want to probably pick this one. And you'll notice not every indicator switches right at the neutral level. Some of them have transitions between 1 and 2, a pH of 1 and 2. So depending on where you want to end your titration at what pH level, you're going to want to select your indicator wisely. So yeah, that's really about all I have for indicators, though, is that you need to know they change color based on what pH they have, what pH they're in, and different indicators change color at different pH ranges, and they have different colors they transition to and from. So there you go.